on November 9th, telescopes around the world caught something that shouldn't exist. A burst of light thin, bright, alive, erupting from a lonely traveler known as 3I Atlas. At first glance, it looked like any other comet. But when astronomers measured the scale, the numbers didn't just surprise them, they terrified them. The jets shooting from Atlas were stretching millions of kilometers into space, some of them even firing straight toward the sun. For comparison, the distance from Earth to the Moon is about 400,000 kilometers. These plumes were more than 7 times that long, carving across the void like cosmic fire hoses. And here's what makes it even stranger back in July. NASA's Hubble telescope saw this same object as nothing more than a faint cloud, a glowing puff of gas barely visible against the stars. But in just a few months, that tiny glow had exploded into something 3,000 times larger. The change is so extreme that even experienced astronomers are struggling to explain it. How could a comet suddenly expand like a living organism breathing in the dark? What force could possibly drive jets of material directly against the sun's radiation? Something that should be physically impossible if these numbers are real. Then, something deep inside 3I Atlas just went nuclear, releasing energy on a scale no natural comet has ever shown before. Because according to every law of physics we know, 3I Atlas should already be gone. A comet's behavior is supposed to be simple. When it approaches the sun, solar heat turns the ice in its core directly into gas. That gas escapes, carrying dust along with it and sunlight. Combined with the solar wind, blows all of that material away, forming a bright tail that always points in the opposite direction of the sun. It's one of the few cosmic rules that never break. Imagine the solar wind as a colossal leaf blower, constantly streaming from the sun at over 800,000 miles per hour. It pushes everything out with gas, dust, even charged particles, and nothing we've ever seen has been able to blow against it. But that rule just broke. Recent images of 3I Atlas show something almost rebellious. Jets of gas firing directly toward the sun, fighting the solar wind head-on. For those jets to stay together for millions of kilometers without being torn apart, they must be incredibly dense, focused, and powerful. It's like watching a snowstorm move upstream against a hurricane. The only way that could happen is if there's an unknown engine, some internal force driving the material forward with unimaginable strength. To fight the sun and win, you'd need power we've never seen in any comet. And yet, this isn't the first time something like this has happened, and the last time it changed our view of the solar system forever. Space has seen this story before. In July 1994, a comet named Shoemaker, Levi-9, passed too close to Jupiter. The planet's immense gravity ripped it apart into 21 separate fragments, each one slamming into Jupiter's atmosphere like a bomb. The explosions were so bright they could be seen from Earth, and the scars they left behind were larger than our entire planet. Then came Comet Holmes in 2007. For reasons no one fully understands, it suddenly flared, growing millions of times brighter in just hours, and releasing a vast cloud that expanded until it was bigger than the sun itself. One moment, it was a faint smudge in the night sky. The next, a glowing sphere of chaos. When ice and rock heat unevenly, the stress inside a comet builds like pressure in a frozen glass. The side facing the sun boils, the dark side stays rigid, and the entire structure eventually fractures. More fragments mean more exposed surface area, more gas, more dust, more jets. And that's what many astronomers now suspect is happening with 3I Atlas. A comet tearing itself apart. Hundreds of smaller pieces, each creating its own fountain of material. But even if it's breaking apart, there's one number that still doesn't add up, and it's driving scientists crazy. According to Avi Loeb's latest calculations, 3I Atlas is losing about 50 billion tons of material every single month. Yet based on its orbit, the comet's total mass is estimated at only 33 billion tons. Think about that, it's shedding more matter than it supposedly weighs. The math simply doesn't math. Does not compute? You can't lose more than you weigh unless you're no longer one solid piece. When Shoemaker Levy 9 shattered, the total mass of gas and dust it released far exceeded what scientists thought the comet originally contained. Once an object fragments, its exposed surface area skyrockets, and the outflow increases exponentially. So if 3I Atlas really has split into hundreds or thousands of fragments, the numbers would make perfect sense. But if it hasn't, if it's still whole, still solid, and still losing that much material, then we're not looking at a comet anymore. We're looking at something entirely new to science. What if 3I Atlas hasn't shattered at all? What if it's still a single, solid body, and yet it's spewing jets strong enough to defy the sun itself? That would mean it's releasing energy far beyond anything ordinary ice or dust could produce, to blow millions of kilometers of material straight into solar wind. The source inside Atlas would need to be immense, like a pressure chamber or reactor buried beneath its frozen crust. Some scientists think it could have a porous, sponge-like structure, allowing volatile gases trapped deep within to escape explosively through narrow vents. Others suspect the core may contain exotic compounds, possibly metallic or reactive, that ignite when exposed to heat. Whatever it is, it's not behaving like a dying comet. It's fighting back a frozen volcano in space that just refuses to burn out. And its orbit only makes the mystery deeper, because it's not just strange, it's backward. Every planet in our solar system moves in the same direction counterclockwise when viewed from above the sun's north pole. Earth does. Mars does. Jupiter does. It's the rhythm our entire system follows. But 3I Atlas, it's going the other way. Astronomers call this a retrograde orbit, the cosmic equivalent of swimming upstream through a river of planets. Only about 1 or 2% of known objects move like this. And they're usually tiny captured moons or debris left behind from violent collisions. What makes Atlas even stranger is its precision. Its path almost perfectly aligns with the ecliptic plane, the flat, invisible disk where all the planets orbit. Statistically, the odds of an interstellar object entering at that exact angle are only about 0.2%, 1 in 500. Imagine the solar system as a giant plate spinning through space. Every planet slides along the surface, moving the same way. But Atlas came in edge on, skimming the plate from the opposite side. That's not random. That's uncanny. But we've seen this play out before, and the last time, it started a global debate about whether we just met something artificial. This isn't the first time the universe has thrown us something that doesn't fit the rules. In 2017, astronomers discovered a strange visitor passing through our solar system a cigar-shaped object named Oumuamua. It tumbled end over end, reflected light unevenly, and, most baffling of all, seemed to accelerate slightly as it left the sun. With no visible tail or gas to push it forward, Harvard astrophysicist Avi Loeb suggested it might be something artificial, a light sail. A thin reflective craft, pushed by sunlight itself. Most scientists disagreed, saying it could be a shard of hydrogen or nitrogen ice. Still, the mystery remained unsolved. But here's where things get interesting. Oumuamua was only a few hundred feet long. 3. I-Atlas is more than a mile wide, weighs billions of tons, and moves on a retrograde orbit opposite every major planet. It's like comparing a falling leaf to a mountain that learned to move. If Oumuamua was a whisper, Atlas is a shout. So what happens when the universe starts shouting and we still can't tell who's talking? Step back for a moment and put the pieces together. 3 facts. About 3. I-Atlas break. Every model astronomers have built so far. First, jets that fire against the sun, stretching millions of kilometers through the void. Second, a mass paradox, losing 50 billion tons of material a month while weighing only 33. And third, a retrograde orbit almost perfectly aligned with the ecliptic plane, where no interstellar object should naturally travel. Put them together, and you get a question no simulation can answer yet. Over the next few weeks, 3 critical tests will decide what Atlas really is: the spectrum of its water molecules, the brightness curve after perihelion, and the path shift once it escapes the sun's gravity. If even one of those signals breaks the model, the story of 3, I-Atlas, changes everything: our science, our assumptions, maybe even our place in the universe. Stay curious. Stay critical. Because this story is just beginning